Thank you. At least you're still awake. I mean, that's good. Well, I mean, it's a great pleasure to being here. I've heard actually that some of the smartest engineers are coming from the Technion. Is that correct? Yeah, that. Who here are engineers? Yes, well. I think we need your help, and I'm going to give a quick, short talk, and it's more to actually ask for your help in two aspects. And to start off with that, first, what you heard before is that air pollution is not very good for you. You heard that noise is not so good for you, but then you heard that green space may be good for you. But there are other environmental exposures, that may have an effect on your health, like temperature, for example. Most of the time, as the temperature gets too high, may also not be too good. You might die. UV exposure may have beneficial effects because we need it to produce vitamin D. At the same time, maybe from some risk, cause skin cancer. So you get different exposures, and of course, you've been sitting here and looking and saying, what I would like to know what I'm exposed to. What is my exposure? I want to go out and have a look, what is my exposure to this kind of things? So, as part of one project that I'm working on, and also David is working on, we're trying to set up a citizens observatory in different places where we bring people together to discuss about their environment, their environmental exposures, and also try to develop technology like sensors to measure their exposure. And I would like to start off my presentation with a very short video to see what we have in mind.
Scientists, public agencies and the private sector already collect many kinds of environmental data that can be used for the benefit of humanity. The Global Earth Observation System of Systems, or GEOS, gathers information from around the globe using space-based, airborne, marine and terrestrial monitoring systems. Recent technological innovations funded by the European Commission now make it possible for citizens to participate actively in collecting data and monitoring their environment. To explain the idea of citizens' observatories, we can look at any modern European city. Air pollution is a real problem, and most cities can only afford a small number of fixed measuring points. These give accurate but limited data coverage. Now imagine we could have numerous smaller measuring stations with individuals gathering data in real time. These mobile monitors, which in the near future will become smaller and easier to carry, can give us a more complete picture of air quality. This is made possible by the miniaturization of sensors combined with the transmission capacities of modern smartphones. Citizens will not only be helping to collect data, they will also get something useful in return. Real-time pollution maps, for example, could indicate alternative travel routes, helping cyclists to avoid heavily polluted zones.
So the aim of CITISENSE is to empower people in environmental decision making, to give them new tools to assess their environment, bring them together in a citizens observatory where they can discuss with other people about air pollution issues and try to influence decision making.
Odors can be a real nuisance. They're hard to measure objectively and so cannot be regulated like other pollutants.
Information from the citizens are important because odor is a perception, it's not just a physical quantity, so we have to try to quantify the perception of the odors by the citizens.
First, a number of e-noses are being set up around the factory. The e-noses are linked to an odor dispersion model. Neighboring citizens make an important contribution by inputting their own perceptions of odors via tablet, smartphone, or internet. Information provided by the citizens will be checked and verified with the other data. Both the public authorities and the industry source will have a better base for informed local action. European businesses can use these innovations to generate services to citizens, industry and governments, creating both wealth and job opportunities. Citizens can benefit not only from the mitigation of the odor nuisance, but also from having an active role in environmental governance. People have always been interested in observing their surroundings. Whereas observation satellites and in situ measuring stations are set up to monitor vast areas of ocean and coastlines, this could now be complemented with numerous smaller observations carried out by citizens. The widespread use of smartphones and the internet makes this possible. Simple apps will enable individuals to assess the transparency, color and fluorescence of seawater.
These three parameters tell you a lot about the oceans, and particularly when you have the three together in one place and in many, many places, which is where citizens come in.
Citizen science, I mean, the idea of the public getting involved in environmental monitoring is really important because it's not possible for government agencies to cover the kind of area and get the level of monitoring that you need.
The citizen source data will automatically be uploaded to the internet, archived, processed and finally made available through a mobile application or web page.
So citizen suddenly has this "I can do it" attitude and wants to contribute and wants to be taken serious.
The European Union is funding several pilot citizens observatory initiatives. It's crucial that the data collected by citizens are made freely and openly available and accessible through the GEOS. Individuals will be recruited to play the role of observers through existing community groups and NGOs, schools and local authorities, plus word of mouth. Knowing that they will have greater influence over the development of their locality will give people a real incentive to become active citizen observers.
You're lucky in a way, because this was the example of Barcelona, but fortunately also you have a citizens observatory here in Haifa, so we're going to start off fairly soon as well. So if you would like to participate in this project and also would like to know your air pollution, you can go and talk to David actually and ask him to participate in the study. I mean, we'll be setting up websites, etc. There will be also discussion that. And a few years ago, I mean, I would ask in the room how many of you have a smartphone. Nowadays I don't ask it anymore because everyone has a smartphone. So, oh, sorry, we got one that doesn't have a smartphone. Two actually, I don't have one, but oh, you don't have one either then. But they're good, the smartphones. Actually now, the idea is actually what we're trying to develop, a part of CITISENSE, but then also as other project, to make kind of the smartphone the center of a lot of other sensors where we can actually measure different things. Is there a pointer on this one? No? Okay, so the idea is here that we're not only interested in air pollutants, but also in noise, UV, electromagnetic fields, where people are, because where people are that determines their exposure. But also there are other sensors that we're using, like video or phone or photos that you can use from your smartphone. That at the same time you also would be able to measure your physical activity levels. I mean, we know Mike told you physical activity is good for you, but also at the same time when you do physical activity you breathe in more, so you may breathe in more air as well, what may not be as good to you that. But I mean, imagine also if you could link this also to health sensors like spirometry or sensors to measure your heart rate or heart rate variability, or other things like questionnaire about symptoms and this kind of things. The idea is that you would use the mobile phone as kind of the network, the center of the network where you collect data, what is being sent to a database, and that you then actually can analyze and share the data with other people in your observatory. Just to give you a little example, what we recently did was trying to find a number of different sensors that measure different exposures and different health effects, and see if we could put them together and put them on a person, and then the person walks around and see what we could measure actually that. So what we can see here from left to right is a machine to measure blood pressure, then one to measure lung function, also physical activity. Here there's something to measure heart rate variability. This is a sensor to measure air pollution. Here we've got the phone. This is a sensor to measure noise. We have temperature in there. And so the idea was put it all together in a little backpack to actually measure for people to walk around. Now, and here's my challenge to you, because you are very smart engineers, because as you could imagine, this is quite big. So what I would like you to come up with actually, with a little box where all these things are together. And do you think you can do that for me? Yeah? If you want to do some projects around this, please talk to David. I mean, he's leading it for us here. So if you have some interest in putting all this in a smaller box, make sure to have a chat and spend a bit of your time on this. Because at the moment what we're dealing with is a kind of a backpack that you may wear on the back. So it's not that comfortable, but at least what it gives you when you have someone walking around gives some really nice data actually to work with that. So what we can see here, this is a person that walks on it for 2 days. This is at the bottom from Wednesday till Friday. And what we're measuring over this time is blood pressure. As you see the little dots going up, you can see there's variability in blood pressure. This is heart rate variability. As you expect, there's heart rate variability there as well. Heartbeat goes up and down. Lung function, emotion. We're also measuring how the person feels, kind of mood, happiness. We were asking the person by sending a little message for how happy you are. Also, we can measure physical activity of the person. Furthermore, what you can see here is, for example, noise measurements on the top, followed by UV, humidity, temperature, and air pollution. And all these kind of things may have an effect on your health, what you can measure. What you can see here from the data, this is during the day where the person is, this is noise. It's going a bit outside, here's inside, and here goes out, where you see some differences. Here also, where the high peaks are, this for UVs, where the person is out, other side, otherwise they're in. And you can see that, you know, there are changes during the day, and in particular, if you look at air pollution, for example, is when the person goes out on the street. Other information what you actually can get from this, also from the phone, is the altitude where the person is. So if you go up to a hill or flat or so, you can actually make information. And you can overlay this with existing maps. Or this is a city, this is also Barcelona, where the person is traveling. From there, the top, up to here, you can see going around. The height of this is actually the physical activity level. So very little physical activity up there, and here much higher physical activity. The person is cycling. This is overlaid with an air pollution map, where you see the more red parts are actually higher levels of air pollution, this NO2, and the yellow parts are lower air pollution levels. Also, what you can get other information about social contacts. We know social contacts are good. This is taking a photo of a person, or what people actually eat. We know that food has an influence on people's health. Other things what we may have look at is using photography. It's also like green space, or for example blue space, what we think what is all good. So as you can see, you can collect quite a lot of information with these sensors, but you know, you get a lot of information. So the question is, you know, how can you actually analyze this? And that's why we also need some smart engineers to bring this all together and do some analysis on this data. Oops, yeah. So this is kind of the what I showed you for the analysis coming together. This is what we see here, some air pollution maps of Barcelona, what you saw before, also Mike showed for Vancouver. And we did a study where we looked at 30 people running around in Barcelona, and we were tracking them. So this is on one day we were tracking the people to see where they were. And the darker the dots, the more physical activity they were doing. The lighter dots, less physical activity. We could overlay this with what I said with the air pollution map, and we actually could calculate what is the inhaled dose to air pollution on different places based on the model data and the actual data. And then actually you can do some very interesting things, because you can see, you know, where do people pick up their air pollution, you know, where's the most time. And what you can see here is people spend a lot of time at home, half the time, or 40% at work, and then in transit, traveling, they only spend about 6% of the time. However, if you look at the inhaled dose, if you look, for example, then at transit, they pick up about 25% of their exposure to the inhaled dose of NO2 in this case while traveling. So it's the place actually determines where it is. Now the question here is always, you know, do you actually put sensors on people? You know, can you guys make very small sensors that is easy to wear by people, or is it better to place them around the city? So that's also what, one of the things actually we're trying out. Of course, it's, I mean, steadily increasing. There are other opportunities. What you see, for example, also Fitbit is quite popular nowadays. It's for physical activity. We see, for example, like Google Glass coming, what gives us great opportunities to actually quote more information. You have the smartwatches and all kind of other things what are actually coming out there. There are many challenges, is what I said. Processing of the data. We collect an awful lot of data. How do you process it and what are you doing with it? Also miniaturization. The sensor, the backpack I had was much too big. I mean, we want to have it this small, I mean, or like an earring, everything together. Issues with battery power. As you know, your phone runs out of battery fairly quickly. We need to have them run much longer. Also, the other sensors need to make longer. Cost, we want to have these kind of things for very low cost. Also, we want to have people to accept them, and there are some issues with ethics that need to be approved. We looked at that. So these are some of the challenges. You know, a very bunch of smart guys, so hopefully you can help us a little bit as well, come up with the idea of, first of all, participate in our Citizens Observatory here in Haifa, or help us, you know, also engineering and carrying out this kind of work. This is my team in Barcelona, and if you're interested to come and visit us in Barcelona, you can come as visit us as well. We're here in the building at the bottom part. You know, if you have enough of all the thinking of the hard work, you can just go to the beach for a little bit to relax. But you're always welcome to talk to us there. Many thanks.